Good morning and welcome to the first of our 15-minute Teach with GIS webinars. We've got our coffee, we hope that you have too, and we're here today to talk about the GIS Visualiser. But before we get into that, Dave, why have we decided to do a live webinar at 7:45 in the morning for 15 minutes?
Well, some people might say it's because we're foolish, and maybe we are. But hey, you're here, so we might as well carry on with that. The idea is that we're going to share 2 or 3 suggestions of ways that you can build GIS into your teaching and then build on that success from there. So you get really inspired and excited in using GIS in your teaching.
Brilliant. Okay. Well, what's the first thing that you want to show me?
So if I head over to the Teach with GIS UK site and click on Teach, I can find my way to the resource gallery.
So the way that we've organised the new Teach with GIS UK site is there are different topic areas that hopefully relate to your geography curriculum and perhaps other aspects of your school's curriculum where you can find resources around that particular theme. So today we've said already we're going to look inside the Visualiser topic.
The Visualiser approach lets us teach across a whole range of topics. So for today we're going to start with this Digital World Atlas.
So talk me through the Digital World Atlas then, Dave. What are we looking at here?
So at the simplest, we've got a 3D map of the world, and it's really easy to switch from that 3D view to a 2D view. And the Atlas is smart, so it knows where in the world we were starting and takes me to that same place again. I'm not just stuck with the base map that I've got on either of those 2 maps. Over on the right hand side here, I've got a little button that looks like a window that takes me into my base map gallery, and I can change the base map that's laid over that globe or that 2D map. So I can take a topographic base map. I can choose to focus on the oceans.
I really love this base map because it flips that traditional map view where all the interesting stuff is happening on the continents, and instead it's like we've drained the oceans and we can see some of that undersea topography essentially. So if you're doing an oceans-based topic, it's a really nice base map to pick to actually explore that in some more detail.
Or if I'm interested in urban geography, the OpenStreetMap base map is a really nice one to use because it's full of rich, up-to-date information about particularly urban areas.
Yeah, I love that when you zoom in on the OpenStreetMap, you can see things like the names of the shops in retail units. So it's really useful if you're doing things like land use surveys. You can pretty much virtually go and do a clone town survey in different high streets around the UK just by using the data that's here in the OpenStreetMap base map.
So let's say I'm starting a new topic looking at favelas in Rio de Janeiro, and I want my students to have an idea of where is Rio de Janeiro relative to us here in the West Midlands. So I've chosen that straight line measuring tool and I've clicked in Birmingham where we are. And I'm going to zoom out and scroll my way south and west to Brazil and just zoom in on Rio de Janeiro and then double click to end my line. So there we have it. 9,000 and a bit kilometres away.
And if you want to, you can change that into miles as well just by clicking on the button there. Because who wouldn't want to?
So there we have it. We've located our case study on the globe in context relative to where we are. And we can start to talk about where that is geographically. So your students might describe that as down and left a bit. Using better geographical language, we've travelled south and west. We're into the southern hemisphere, in South America, in Brazil. We can start to use some of that good geographical description. Those same measuring tools, those same measure tools are also here on the 2D map. So if I'm interested in maybe comparing the size of Greenland with the size of Africa, they look kind of similar on my 2D map. But if I pop out my measuring tool, I can see that Greenland, just over 2,500 kilometres in length, compared to Africa, which is over 8,000 kilometres in length.
One of the things that I really love about being able to switch between 2D and 3D so easily inside this app is that it helps us explore with our students the way that maps can distort the world, because we're having to take that 3D globe and flatten it out in order to create this 2D representation. So having that ability at the click of the button, I think, is really fantastic. I've got another use of the measure tool actually that I'd like to share with people. I think it's really helpful to get a sense of scale of some of the landforms and features that we might be studying as geography case studies. So if you wouldn't mind, let's navigate to one of my favourite case studies. Let's go to Mount Vesuvius. So Mount Vesuvius, a really interesting volcanic case study, obviously has those ramifications in terms of history as well, in 79 AD with the catastrophic eruption that destroys Pompeii and Herculaneum and those other fascinating archaeological sites in the region. So exploring it in the 3D viewer, I think, gives a real sense of kind of the scale of this volcano, the way it dominates that kind of Bay of Naples area, and gives students a little bit of a sense of what it would be like to be there in person. But I also quite like to bring out the measure tool to personalise that scale a little bit in terms of geographies that our students live, the geographies that our students know as their day-to-day. So if we take a measurement across the base of the volcano and just get a sense of scale there, so it measures sort of roughly just under 10 kilometres, depending on quite where we take that measurement from. 10 kilometres, for us particularly, if we're drivers or if we sort of do a regular park run at the weekends, it kind of makes sense for us as a measurement. But I think it can be quite alienating for some of our students who don't necessarily have a strong sense of what 10 kilometres actually means. So one of the things that we can do with the measure tool is we can take that 10 kilometres and we can drop it onto a geography that they are more familiar with. So Dave has come into the West Midlands again, and we're just going to drop 10 kilometres on top of Birmingham. And we can see straight away the scale of that volcano when we put it into our kind of students' known, understood context. It would completely destroy a major part of the city centre. It would totally dominate, the entire region here. And obviously we've got that ability to take these measurements for any landform that we're interested in. So it doesn't just work for volcanoes, we could do the same thing for glaciers, we could do the same thing for other megacities to look at them in terms of their comparative size. So I think that's a really effective use of the measure tool to do some of that compare and contrast with the areas that we know best. So another use of the measure tool is to actually go and understand some of the landscape features that we might be studying in terms of their scale and dimensions. So where have you taken us to, Dave?
So we've headed over to North Wales and we're in Cwmidwal, that textbook glaciated landscape. So we might be interested in talking about, well, how high is the back wall of this Cwm? So I'm going to start with a click at the top there, and I'm going to make my way down just to the stream outlet at the edge of the tarn in Cwmidwal. And we can see if I spin this around that I've now got a measurement that's worked not just in one dimension, but in 3 dimensions. So the height of that back wall down to the stream is 319 metres.
Fantastic. And we could take that measurement and we could go and we could compare it to the same kind of glacial features in, say, an alpine landscape or another glacial area that we're interested in doing a compare and contrast study with. I also just want to pick up there, Dave, as you were using that measure tool, there was something quite interesting happening on that landscape. There it is, this kind of interactive contour that appears. I think that's quite a useful teaching tool when we're trying to unpack the idea of what a contour actually is, being able to see it demonstrated in the landscape.
I agree.
Good,
Yeah.
I'm glad.
Yeah, it's a really lovely tool, being able to slide your cursor up and down and join up all of those points that are equal height. And if I've taken a really sort of oblique view, then it kind of becomes quite obvious that I'm joining points of the same height with these squiggly lines.
So I just wanted to take us over to this part of the UK coastline, the Holderness coastline that I know a lot of us will be using as kind of a case study with our students, a very popular one, and to just sort of unpack some of the ways that we can use the Visualiser to explore students' existing understanding. So taking this kind of mesoscale view, looking at the entire length of this coastline, can our students clearly identify where the headland is, for example, and where the spit is? What does that tell them in terms of the direction that Longshore Drift is operating in? So we can use the Visualiser to unpack some of these concepts with them, to check their prior learning, particularly if they're coming to us maybe from different GCSE contexts and we're going to be recovering some of this material at A-level, or just as part of a lesson sequence. Maybe if we've looked at this a few lessons previously, we can come and do a little knowledge check in terms of have they managed to retain that information. So let's take a look at some of the other features that are here in the Digital Atlas. What did you want to show us first, Dave?
So one of the things that you probably noticed and really wanted us to click on and talk about is this list of layers over on the left-hand side. If I head over to this earthquakes and volcanoes group, and I'm just going to show what we've got there. And what we're currently looking at are recent earthquakes. So these are actually earthquakes that have happened in the last 7 days. So we can see they're occurring as these coloured dots around my map. The size of the dot indicates something about the magnitude of that earthquake, as does the colour. So larger redder dots are larger magnitude earthquakes, smaller yellower dots are smaller magnitude earthquakes, and the ones that are kind of fading out a little bit are the earthquakes that took place longest ago.
And can we see the legend information for that as part of this app?
We can. So there's a button down the bottom here, which is our legend. So if I click on that, it will show me the legend for this layer or any layers that I've got loaded on my map at the time.
Cool.
Also, if I click on any one of those earthquake features, I get a little pop-up box to tell me all about that event.
So the idea with these data sets then is that we're making it really straightforward to find data sets that we think you're likely to regularly use in a classroom. So around topics that we know people are teaching on a very regular basis, rather than having to go into ArcGIS Online itself and hunt them down, they're just here available for you in this digital atlas. And our thinking is that you can combine some of these layers to address different topics and to address kind of content for different year groups. So one of the things that I quite like to do, a common misconception that I've often sort of come across in my teaching, is this idea that earthquakes occur in hot countries. And I'm not sure where this came from, but one of the things that's quite nice to do is to just address that misconception directly by looking at something like the global temperature layer alongside that earthquake layer, and seeing that actually we've got earthquakes that are occurring in all sorts of different temperature zones. It's not just in the hot places, it's in some of the cooler regions as well.
I can load on those plate boundaries. We can start to have conversations around where are these earthquakes predominantly occurring and where are the exceptions to the rules that we might have spotted as well.
Yeah, and combining that with some of the tools that we've got here, how far is that hotspot from a plate boundary?
Well, let's measure it. So this is probably the closest plate boundary, maybe not. So about 3,500 kilometres to the nearest plate boundary.
So this is serving as a springboard for some geographic discussions around why this phenomenon is taking place.
Plate boundary.
So this is serving as a springboard for some geographic discussions around why this phenomenon is taking place, why it's anomalous compared to those distributions that we can see around the tectonic plate boundaries. And that really is the heart of the Visualiser concept. The idea is that this is something that you can do as a front of class exercise on a regular basis around all the different topics of interest that you're addressing. So every case study, every place, every student in your classroom is here inside this digital atlas, essentially. That's pretty much everything that we've got time to show you folks today. We'd love to invite you back for the next in our webinar series. And if you've enjoyed this live stream today, then feel free to get in touch with us on social media and let us know. Feel free to share the link with other people that you think would enjoy learning some more about the GIS Visualiser as well. And we'd always be happy to see you face to face at one of our training sessions. You can find out more about that in the events tab on the Teach with GIS website. Thanks very much for watching, guys, and we'll see you soon.